My name's Scott Gassich with Haas Automation, and I'm here with Matt Silva, one of our application engineers. And we wanted to take a few minutes today to show you the advantages of drilling holes with through spindle coolant. All right, so Matt, tell us what we're going to see today.
You're going to see a 6-hole bolt pattern. The first set, we're going to be using high-speed still, peck drilling, using traditional flood coolant.
Okay.
The second set, we're going to be using through spindle coolant with a carbide drill. And I'm just drilling in one shot.
Okay, so the big difference we're going to see is through spindle coolant, and that's going to allow us to punch the hole in a single shot rather than peck drilling with that high-speed steel drill.
Correct.
Okay. Now we're doing this in aluminum, correct?
Correct.
Okay. And these hole sizes are?
1/2 inch in diameter.
And we should expect to see a much faster cycle time on making these holes.
Correct, and a better quality hole as well.
Even better. Let's go ahead and run it.
All right.
Okay, so I noticed that we're not using a spot drill. Why is that?
So we're not using a spot drill just for demonstration purposes. I want to give you an apples to apples comparison using high-speed steel versus carbide with TSC.
Got it. So we can actually look at the cycle time it takes to make these 6 holes apples to apples. The difference is flood coolant versus TSC and the use of the carbide drill versus the high-speed steel.
Right, that's correct.
Okay. Now I notice we're peck drilling. How deep is that peck?
250 thousandths.
And why do we have to peck drill
So,
high speed?
2 things. We have to break the chip,
Okay.
and we also have to retract to allow the coolant to fall down inside the hole to evacuate the chip.
Gotcha. So that action of coming up and down is what gets the chips out of there.
Exactly.
Whereas we could see the through spindle coolant coming on.
We're running 15,000 RPM.
That's 15,000 RPM, a single shot, and wow, we're already on the last hole.
Yep.
And we take a look at that cycle time. So we did those 6 holes using the high-speed steel drill and flood coolant in almost 50 seconds, and it took a little over 20 seconds for us to punch all 6 holes with the carbide TSC.
Correct.
Okay, let's take a look at the hole quality.
All right.
So let's take a look at that first set of holes. Tell me what you see there.
Okay, where we use the high-speed steel, you can actually see that there's some tool marks, so the finish isn't very good. And also on the top, you can see that the hole's bell mouth, proving that we should have used a center drill to actually prep this hole.
Okay, when we look at the holes with the through spindle coolant and the carbide drill, see a much better hole.
Much better finish, and you don't see that bell mouth. It's definitely a better hole.
Got it. So really what we end up with is we make holes faster, we make a better quality hole, and we're able to make more holes per tool by using through spindle coolant and carbide drills.
Correct.
That's real Haas value. That's helping you be more productive and ultimately make money faster. Matt, appreciate the time.
All right, thanks, Scott.
Thanks.